For now, I'm going to move along and go to the next speaker, which is, again, Kevin Smith, the Vice President and Creative Director of BitSpace, who's going to follow up from his previous session and show us a little bit of Fusion 360. This, again, will be followed by a longer length session, which is Thursday, and that is 4:30 p.m. Central Time this Thursday. So, Kevin?
All right, everybody. Thank you so much for coming back. Let me get my screen shared up here, and everybody just might as well take their socks off now because they're about to be blown right off. So, took the first design prompt that was submitted because I needed the most amount of time I could have to kind of demonstrate the speed and efficiency of Fusion 360. One of the questions in the Q&A was about developing an orthopedic horseshoe or some sort of custom fitment maybe option for horses in the not one size fits all approach to design. So taking that inspiration, first things first, right? We don't just kind of fly blindly into an idea. We want to do a little bit of research. So, time being a little bit of a limiting factor here, my research was pretty limited. I needed to know the size of horseshoes. I needed to know kind of their general geometry, their general thickness, things like that. And then also what maybe was meant by orthopedic or the different kind of opportunities to help animals in ways that, completely outside of my realm of understanding until about an hour ago. So things like shock dampening, anti-slip, pressure distribution, kind of all these things that affect humans, which I am. So I kind of like, oh, okay, well, I sort of get where we're going here. I tried to create a parametrically constrained horseshoe. So here we go. All right, so in however many steps that was, we have ourselves a horseshoe. Now, a little bit of creative flair, a little bit of hasty design judgments, a little bit of frantic modeling has led me down some, design constraints that maybe aren't so great. But what are great are these options here where I can do things like change the parameters of this design. So I kind of was thinking ahead that, again, not one size fits all. So if, for instance, let's see if I break my model. Excellent. No. So let's just say that, the horse tooth is something that we can quantify and measure, and we can actually take these inner widths and things. Or let's say we need an overstable shoe, so we can add just a little extra flange to the model. So you can see how I can grow and shrink this project. So once I've created it, it's not just a one and done, right? Fusion allows me to edit my parameters and kind of create geometry that is expandable, which allows for kind of infinite iteration. So in theory, if I took a day to do this, or a week or a year, you could develop kind of a parametric shoe like this that you could adjust the pitch angle of, the thickness, the weight, the strength, like the maximum bearing capacity, all of these things, just through the power of design and kind of understanding how Fusion wants you to work. Now, I'm going to stop there. Jeremy, how am I on time? I didn't start my timer.
We've got a couple more minutes.
Couple more minutes, perfect. So I am just going to show off some of the basics. So what I did to begin with, right, is I didn't want to fly alone. So I imported a shoe horse. Now, again, this is where you talk to the expert to find out whether or not this thing just looks cool or if it's actually really useful, right? I went with looks cool because I haven't yet talked with a consultant. But it seemed like it was a good law of averages for the kind of horseshoes that I was able to come up with, and then generated a sketch around that idea. So kind of summing up its parts, what is a horseshoe made of? It's kind of a set of ellipses. There's some kind of angular contact geometry that comes from the center. And then we kind of extrude that out. There we go. Let's kind of turn off some of this stuff. And we kind of have this rough shape. Imagine like we're starting with a massive block of metal. Like we're going to CNC mill the crap out of these things. What is the fundamental shape this thing is? Can it be cut with a chop saw to save tons of time? And then can we start to round over those corners and start to make the contact patch with the ground rounded over so that maybe it's less of a abrasive front hoof kind of impact. Again, all things that I would have to vet and talk to somebody who's an expert on the matter. And then how do we affix it to the animal? So, you know, I understand that they're just kind of tacked in place. One of those things, I'm sure there's better ways to do that with modern technology, but I wanted to make sure that I could adjust kind of the placement of those. So, you know, if hypothetically one area of the hoof is stronger than another, maybe I can kind of back these off a little bit. Oh, here we go. Fusion's getting crazy. Maybe that wasn't such a good idea. Let's just undo that. But let's move this one just to see what happens to the model. So finish the sketch. And does it break everything? So we're going to move forward. And then what's this guy? So this guy is kind of that relief pattern to kind of take some of the weight out of the horseshoe. And then we extrude that out. And if I turn off some of these guys, right, we kind of end up with that, the beginnings of the final result. Just to kind of show you again how the parametric aspects of the software work. I'll move this guy over here, hit OK. And my bolt holes kind of stay 1 inch apart, right, which could be important. I don't know if it is, but again, more research equals better solutions. But I don't have to redo everything all the time. I just kind of change my mind, and Fusion says, okay, that's cool, let's keep going. Speaking of which, let's just fast forward here. So I just kind of tuned up the model a little bit, added a little bit of chamfer, imagining that any 90-degree inside angle, not only is it crud for 3D printing, because it's a stress riser, but also I imagine it's crud for crud, right? You know, you have a lot of stuff that's going to get stuck in there. So I started to chamfer this out and kind of make it a little bit more mud clearing, if you will. And then last but not least, you know, we don't want razor sharp edges. So I just kind of like smoothed out the top portion here. And then I rotated it so that it is facing the almost the correct way. And in a nutshell, right, that was about an hour's worth of work, plus some tuning into these amazing presentations that have just been utterly incredible about, you know, everything from empathy and design to engineering solutions that I hadn't even heard of till today. So pretty fantastic stuff. But all I'm saying is, even as a side project while you're doing other things, Fusion's pretty awesome at creating content. And I hope you guys maybe stick with me on April 30th, where we're going to spend a little bit more time and maybe walk through a project together, make some cool stuff together. So I think that's my time. And I just want to say thank you all very much. And I hope that you guys continue to enjoy the rest of the day.
Thanks so much, Kevin. That's great. And again, that's Thursday at 4:30 p.m. Central for the longer length session. And I highly recommend that you folks join for that because, you know, there's so much to see in Fusion 360 and you'll see a lot more of it in that session. It's just such a powerful tool. And I'll also mention that for such a powerful tool, there are also free licenses available for educators and students as well as startup businesses. So it's a pretty compelling platform to look at for your CAD and modeling needs.